In this video, we will go over how to classify using logistic regression. Let's say we want to determine if the phrase, "I am happy," has positive or negative sentiment. In other words, we want to classify the sentence, "I am happy," as either 1 or 0. To classify text using logistic regression, we need to have the following requirements: a feature representation of the input, a classification function to predict the class based on the input, pre-trained weights and biases, and a decision boundary. Let's start off with the feature representation of the input. Let's say that we use hand-labeled features representing text data. In this case, we are choosing to have the elements of X represent the word count. In this case, there are 3 words in the phrase, "I am happy," the number of positive lexicon words like good, happy, or excellent. In this case, there is 1 positive lexicon word, happy, and the count of no. In this case, there are 0 no's in the statement I am happy. Now we need a classification function to predict the class. We will use a neuron. We learned that to calculate the output of a neuron, we apply a nonlinear activation function to the weighted sum plus the bias. This gives us the probability that the class is positive given X, our vector of features. In the case of sentiment analysis, a class of 1 represents positive sentiment. Now we need to have trained weights and biases. Let's say that our given weights and bias are the following vectors and scalar value. Remember that the values in the weight vector tell us how much each corresponding feature matters in the calculation, and that the bias just changes the final output value. In this case, word count matters 0.3, positive lexicon words matter 1, and count of no matters -0.5, and the bias is 0.1. Finally, we need a decision boundary. When we calculate the probability of the class being 1 given the input vector X, we get a probability, not an actual class. So, we need to determine what probability is high enough to actually assign a class of 1. In this example, we will set the decision boundary to 0.5. That is, if we get a probability higher than 50%, we will assign the class to be 1. And if the probability is not greater than 50%, we assign the class 0. Now that we have all of our requirements to classify with logistic regression, we can perform the actual calculation. Using all of the requirements we gathered, let's calculate the class. We know that to calculate the class, we need to use our neuron equation, which is the activation function, in this case sigmoid, applied to the weighted sum plus the bias. We can plug in the weights vector and the feature vector, as well as the bias. Now we can calculate the weighted sum using the dot product. 0.3 times 3 is 0.9. 1 times 1 is 1. -0.5 times 0 is 0. 0.9 plus 1 is 1.9. 1.9 plus 0 is 1.9. And now we can add together the weighted sum, 1.9, plus the bias, 0.1, which gives us 2.0. We can now apply the sigmoid function onto 2.0, which gives us a probability of 0.88. Now that we have the probability of the class being 1 given the input X, we can use our decision boundary to determine what class to assign the text. Since the probability of Y being 1 given X is 0.88, we can check the conditional. 0.88 is greater than 0.5, so we will assign a class of 1, which is positive sentiment. These videos were inspired by Josh Starmer at StatQuest. Be sure to check them out.